So on Friday, we were continuing on with our exponent laws, okay? And then we introduced this idea of a negative exponent. Let's just get a new page. Okay, so we took a look at what does a negative exponent mean, okay? And we learned that by definition, it means that when we deal with the negative exponent, we just write the reciprocal of the base, okay? And then whatever the reciprocal is, that now has your new exponent, but now your exponent is positive, okay? So for example, if I had x to the negative 3, this would be, write the reciprocal of the base, so just flip the base, right? And your base is over 1. Okay, so you write the reciprocal, okay, and then everything gets to the power of 3. Now, one of the things, and I'm just going through the notes and seeing what we called it. Oh, in lesson 5, I'm just looking for a page number. On page 10 of your notes, okay, we have a whole bunch of the exponent laws. Okay, if you want to just flip there real quick so that you can kind of follow along with me. Okay, we had something called the product law. Okay, on page 10. Okay, that's the one that we just did here, right? When we said when we're multiplying bases, we can add the exponents. So that was called the product law. Okay, we had the quotient law. And that said that when we're dividing, okay, or you might see it like this. Okay, these are both the same, that we would subtract the exponents. Okay, then we had our product of the product. Okay, and that was when we had, right, we took an exponent of an exponent. So this one was product of a product. Okay, and that one was where we got to like multiply the two. Okay. Sorry, power of a power, product of a product. It's Monday, right, guys? You will be gracious. Okay, power of a power. Feel free to put your hand up and correct me on that. All right. And then, okay, then we kind of like sort of snuck these two in. We didn't have a separate lesson for them. Okay, but we've kind of been doing them on the fly when we do this. So I just wanted to draw your attention to it. So we have the power of a product. Okay, and this one, this example, okay, this showed that, there's all my nice lines and colors. Sorry, just a sec. My board is being, there we go. I like this one. Okay. Okay, this means that when you have things that are being multiplied together in here, okay, that we can, okay, make sure that everything inside of the brackets gets the exponent value. Okay, so the A would get the exponent, okay, and the B would get the exponent. If you had a coefficient in there, if you had a number, okay, the number would also get the exponent too. So say, for instance, we had 2xy squared, okay? And I said, let's square that. Okay, so what you would do is you would just square every single thing on the inside. So you would do 2 squared, you would do x squared, and then you would do y squared, squared. Okay, or you could look at it this way, 2 squared, y squared, and then you would do your power of a power, 2 times 2. So this would become, okay, guys, when you have 2 squared, do I want it to stay 2 squared? No, I want you to actually like tell me it's 4. Okay, that one's an easy one. Okay, so 4x squared, sorry, my x's are sloppy today, y to the power of 4. Okay, so you can see that every single thing in here got squared, including Okay, so we had to multiply for that one. Okay, so that's the power of a product. Okay, something very similar to this one is called the power of a quotient law. Okay, and that just means what happens if I have, okay, like a stacked question. Like what if I have A over B, okay, and the whole thing is to the exponent m. So I know that we did a couple of these questions. People were kind of maybe not sure about that. Similar to this one, everything inside the brackets gets the exponent. The A gets the exponent and the B gets the exponent. Okay, so I want you to know that these are the same thing. So if we had 2/3 squared, okay, you would square the 2 and you would square the 3. So this would become 4 over 9, right? 2 squared is 4, 3 squared is 9, okay? So just so that you know, when we have brackets, because now we're going to start doing, like, we're not just going to give you guys, like, these are the laws and they're pretty simple, okay? We're going to start doing some combination work, okay? And so we're going to see a little bit more of that. So if we go back to our notes, okay, what we learned is, okay, when there's a negative, we just write the reciprocal, okay, and the exponent stays as it is, okay? Convention says that whenever you're doing your work, if your answer has a negative exponent in it, that you just rewrite your answer one more time with a positive exponent. Okay, so I don't want to see anybody's boxed answers like this is my final answer with a negative exponent in it. Okay, because you'll lose marks on that one. So for example, okay, so this one we didn't like necessarily talk about it. We just kind of like said how when you're doing, this one is your example of the power of a product. So you were able to put the exponent in, and so we multiplied it in, and so we did -1 times -3 to get us our +3, -2 times -3 to give us our +6. Okay, this one, okay, we did write this one out, but I just wanted to go over it again, okay, because I think we were maybe a little bit rushed. Okay, so for this one, okay, we could do our power of a product law first. Okay, so we're going to do the -2, okay, for every single term. Okay, do you guys understand that there's 3 terms inside this bracket? There's the coefficient, which is 2. There's your variable A, and then there's your variable B. Okay, so all 3 of those things will get this to the power of -2 applied to it. Okay, so this is going to be -2, sorry, not -2, guys. This is going to be 2 to the -2. -2 times -2 is a to the power 4. And then B2 times -2 is -4. Okay. So this is where I think I kind of lost a couple people. So remember that you can always write anything over 1. Okay, so just imagine in your mind that there's always a bar right underneath your expression here. So when you see a negative exponent, that just means that this is going to drop down below the bar. Okay, it's going to go on the bottom. So this one also has a negative exponent, so that means that the B is going to end up on the bottom. Okay, the B is just going to travel down to the bottom here. So what ends up happening is I have, okay, the A to the power 4 stays where it is because it's positive. It's good on the top. A to the power 4 stays, but the 2 drops down to the bottom. That gets rid of the negative. It's still squared. The B drops down to the bottom. That gets rid of the negative. It's still cubed. Okay. As a final answer, I would love to see you guys just give me 2 squared as a 4. Oh, which one isn't right? Nope, they're both right. Okay. Okay. So I don't want it to stay 2 squared. I'd like to see that as to the power 4. All right. Let's take a look at, okay, these ones. Okay. They look, okay, when we have fractions and stuff, they look a little, I'm going to say messy maybe, okay? But don't worry, we're just going to be doing the exponent laws on them. One of the things that's really helpful, okay, and then I'm going to help you guys set up, is if we stack coefficients with coefficients, and then the same letter variables with each other, you're just going to be able to see it a little bit more easily. Okay, so for example, okay, I'm just going to like write these a little bit more spaced out so you can see what I'm talking about. Okay, I'm going to write the 12 and the 4 kind of separate. I'm going to write the a cubed over a squared, and I'm going to write the c with these fractions. Okay, so see how the coefficients line up, the a's all line up, and the c's all line up. Now you can do your exponent laws. Okay, what's 12 divided by 4? Okay, that one we can do. That one's just 3. Okay, when we are doing our division, right, we subtract the exponent. So 3 subtract 2 gives me 1. Okay, now this one, okay, you might off to the side need to just remind yourself 3 halves subtract 5 halves. Okay, 3 subtract 5 gives me -2 halves. Okay, guys, simplify before you put it back into your work. -2 over 2 is the same as -1. Okay, so we have c to the -1. That's our first step. The second step is just making sure that our answer has only positive exponents. So what this means is, because the c has a negative, we're going to draw a line and we're just going to pop the c down to the bottom. Okay, and it's going to become a positive one on the bottom. Okay, so our final answer here is 3a over c. Okay, so this part here just dropped down. Okay, I think once you get it, like I think you guys are going to have fun with the negative exponents, right? Because if the negative is on top, the variable and its exponent just drops down. Okay, what happens? I'm just going to do a little on the side here. Okay, here's my little thought bubble. Okay, guys, what happens if we have a b to the -2? Okay, like we did all of our math and somehow or other, like this ended up being our answer. Okay, what if we have a negative on the bottom? Okay, what's the reciprocal of that? Where does it move to? Kennedy, what were you saying? Yeah, you just flip it again. So this, guys, if you have a negative on the bottom, that just means that the b is going to come up to the top. That's all. So this would become ab squared. Okay, so you'd still take the exponent with you, but now the exponent's positive, and so it would just come up to the top. Okay, so dealing with positive and negative exponents, you basically just have to say, is this on the top or is this on the bottom? Okay. So let's try this one. Okay, so let's separate. So some of it, before you separate it out, if there is a power of a power, you got to do that first. Okay, so we have 14, we have x4, we have y to the -3. Okay, on the bottom, we first have to do this. Okay, where we put that squared through all 3 of those terms. So the 6, okay, the 6 gets squared. Are you guys okay? I don't want to write 6 squared. I want to go right to 36. Okay. So the in between here was, I don't want to write, I don't like, you know, for some of these ones, if it's squared or cubed, just write the number. Okay, those are ones that we can handle the numbers. Okay, so that's where the 36 came from. I squared the 6, and now I'm going to square the x, and I have y squared. Power of a power, I'm going to multiply my exponents. Okay, now I'm ready to, okay, 14 divided by 36. Okay, how do we simplify that? Well, we would look and we'd say, okay, well, what number can I divide both of them by? Now, again, I want to show you guys, you know, your calculator can help you out with this. Okay, if I go over to my calculator and I do 14 divided by 36, it will give me a decimal. However, if I go math, fraction, okay, 7 over 18. It just gave it to me in simplest form. Okay, powerful tool to do that. Okay, or you could have looked at it and said, I could have taken a 2 out of top and bottom. Okay, 7 divided by 2, sorry, 14 divided by 2 is 7. Okay, 36 divided by 2 is 18. Okay, so both of those strategies. So for you mental mathers, you're just saying I'm going to divide top and bottom by 2. Okay, and for if you need to use your calculator, you can just put the numbers in your calculator and do your math fraction in order to get that. Okay, so we have 7 over 18, we said, and I'm just going to like draw a longer line. Okay, 7's on the top, 18's on the bottom. Okay, we're going to subtract our exponents because we're dividing. 4 subtract 2. Okay, guys, when we do this, okay, our numbers are all going to stay on the top. Okay, when we do this subtraction this way. Okay, so 4 subtract 2. Okay, we're on the top. -3. Okay, -3 subtract 4. Okay, is -7. Okay, it starts off on the top. When you write your answers, you're always starting off on the top. And then, okay, then we can see that we have a negative exponent. So this guy is just going to drop down to below. Okay, so our final answer is going to be 7x squared over 18y to the 7. Okay, when you have something like this, okay, in example L, okay, we have 2 choices. We could simplify in the brackets and then deal with the -2, or we could deal with the -2 and then do our brackets. Okay, both strategies work. Okay, so it's kind of, sometimes it's what you see first. Some people like to simplify first and then deal with things. Other people are like, that -2 exponent, I just want to like deal with it. I just want to write the reciprocal and then I don't have to deal with any negative exponents. Okay, and having to remember to like bring a negative in and that kind of thing. That's kind of my preference. Okay, so what I'm going to do is I'm going to write the reciprocal so that I get rid of this negative exponent. So the reciprocal, right, is just everything that's on the bottom now goes to the top. Everything that's on the top now goes to the bottom. So this is going to be 15a to the power of 6, b to the power of 7 over -3, a to the power of 3, b squared. Okay, and all of that is squared. Okay, so let's simplify first. Okay, because remember, BEDMAS, brackets first, then exponent. Okay, so simplifying first before you apply that squared will just clean things up really nicely for you. Okay, so what's 15 divided by 3? 15 divided by -3. Okay, that one you can do -5. Okay, and then we have it 6, we have our a's. 6 subtract 3 gives us a to the power of 3. 7 subtract 2 gives us b to the power of 5. Okay, and then all of this is still squared. Okay, and then I'm going to square everything. So don't forget, when I square this, I'm squaring the -5. Okay, so this becomes 25. Okay, power of a power, 3 times 2 is 6. 5 times 2 is 10. Okay, they're all getting, okay, they're all getting this exponent. Okay, does that feel better? Like the whole negative exponents? I mean, Friday was kind of fun and we did a lot of board work. Okay, but I wanted just to make sure that we know like where things end up when we're dealing with a negative exponent. Okay. Let's do another example. Okay. Then, okay. Here we go. Example number 4. Sandra found this solution for the following power. Okay, identify her first mistake and write the correct solution. Okay. So when you do your error analysis, you can kind of see if you can spot their error, or again, I like to do like my answer first because we have to write the correct solution anyway. So I'm going to write the correct solution and then kind of compare it to what she did. Okay, so what I would have done, and I'll try going left to right the same as she did. So if this was the original question, Okay, negative 5 over 2. Okay, so she dealt with the negative first, so she wrote the reciprocal. So 25 over 9, okay, 5 over 2. I can see right away what she did wrong. Okay, she flipped the exponent. Okay, never, ever, ever are you going to flip the exponent, just so you know, ever. Okay, the only thing that gets the reciprocal is the base, right? The thing that's in the brackets. Okay, so that was her first mistake. So I could even write that here. Her first mistake was flipping the exponent. Okay, and then I have to write the rest of it. Okay, so now what happens is, okay, she remembered that on a fraction, okay, the denominator, this is a 2, the denominator becomes the index. So whenever you see an exponent that is over 2, it means that we're going to be taking the square root. Okay, so that's where the square root sign came from. Okay, was the denominator became the index, and then this whole thing is still to the power 5. Okay, so that part's right. Okay, and so then she actually took the square root. The square root of 25 is 5, and the square root of 9 is 3. Okay, so we simplified inside the brackets first, and then now we get to do 5 to the power 5 and 3 to the power 5. That everybody needs their calculators for, because I don't think any of us could do that in our heads. Okay, and so then we would, okay, make sure that you remember with your calculator. Okay, so 5 to the power 5, so 5, and you're going to use this caret button right here. Okay, and then it will give it to you as an exponent. If you have a TI-83, an old one like mine, okay, it might not show it to you as like a upper thing. It might actually just show you the caret, which is okay. Okay, 3,125. And then we have 3 to the exponent 5 as well. Okay, 243. Yeah, 243. Whoops. There we go. Okay, and again, your calculator, okay, okay, could confirm that that's in simplest form. Okay, so then we know that that's our final answer. Okay, so yeah, final answer was okay, this step was okay, this step was okay, but somehow she like messed up with that exponent. Okay, so before we pull out our books, okay, what I'm going to do is I'm going to give us 10 minutes I'm going to hand back our radical quiz.